So, we like to factor so that we can solve. And one of the first steps in factoring, well, the first thing you should always do if you can is factor the GCF. The GCF is also known as the greatest common factor. Let's take a look and see what I mean. If we have an expression that looks like this, 3x plus 9, there is a factor of 3 in 3x and a factor of 3 in 9. So what are factors exactly? Ooh, maybe that might be useful for us to discuss for a moment. Factors are things that are multiplied together. So if factors are things that are multiplied together, you might recall when we have a number like 24, we can break this down into prime factors. We divide by some number and then divide again, and we keep dividing and dividing until we can divide no more. And when we've divided till we can divide no more, these numbers down here at the bottom we call prime factors. Well, why the heck are those things called prime factors? Well, because they're things that you can multiply together to get back to that thing we started with. So it turns out that up here, when we have 3x plus 9, there is a 3 times x. And there's also, to get 9, there is 3 times 3. So there's a common factor of 3. Just take a look. Here's a 3, and here's a 3. Now, I know there's a duplicate of that 3, but that's okay. So what we end up doing is this. We say, hey, it would be so cool if I could factor out that greatest common factor. And the way we do it is we sort of undistribute. We take that 3 out front and everything that's left over, in this case there's an x and a 3, and we have factored the GCF for 3x plus 9. We just took, there was an extra 3 in as a factor in here in the 9. There was an extra 3 as a factor in here with the 3x. We just took it out, and then we put everything else in parentheses. That's called factoring the GCF. That's a useful tool when trying to solve equations. So let's walk backwards and see an application for factoring the GCF. See this equation here, 4x squared plus 3x equals 0? I'd like to solve this guy, and using traditional methods like what we do for linear equations, they won't work. It's hard to get x all by itself unless we factor the GCF. In this case, this term here has an extra x, has 4 times x times x. This term has 3 times x. So x is a common factor between these two terms. So what I'm going to do is factor out that greatest common factor, or the common factor between the two terms. And by the way, you don't always have to factor out the greatest common factor, not to start with. You just start factoring out any common factor, and then if you see more factors you can factor out, you keep doing it. In this case, by taking the x out of 4x squared and 3x, I'm left with x times 4x plus 3. And this allows me to solve this equation the same way that I would solve regular linear equations, even though I started off with a nonlinear equation. This guy's known as a quadratic because power of 2. Anyways, I'll use my regular techniques, and the way I do it is I use this fancy thing called the zero product property. So what is this zero product property? Well, I think it's on your magic spell sheet. If it's not, it should be. I'm gonna help. You're gonna explore with me, and you're gonna see if you can figure out what this thing is. So what if I have something like 3.14 times negative 27 times 2/5 times x times 134 times 5.7, okay, and all of that is equal to 0. I'd like you to help me solve this baby. Can you pause and try solving for x? Okay, I'm assuming you paused and hopefully you solved. Hopefully you came up with the idea that in this case, x equals 0. Why? Well, if I have all these weird things multiplied together and it equals 0, then one of them must be 0. And since the only thing here that's not 0 is x, or the only thing here, yeah, I mean, these are all not 0. Since this x must be a 0 in order for this to be true. That's the essence of the zero product property. The zero product property tells us that if we have something times something else, and it equals 0, then one of these guys must be equal to 0. And so up here we can use that property in order to solve. So let's finish this guy off with the zero product property based on our factoring. And what we say is this, is that if x times 4x plus 3 equals 0, then either x equals 0, sort of like in our example right here, or 4x plus 3 equals 0. This is a little bit like what we did for absolute value equations. We said, hey, there must be two possible values. Now, in zero product property, there could be more than two because we could have a bunch of things multiplied together. But in this case, if it's x times 4x plus 3 and it equals 0, then either this guy's 0 or this guy must be 0. So we just solve each, and that's how we get our answers. This one, obviously, is already x equals 0. This other one over here, we just do everything we would do for a linear equation. Subtract 3 from both sides, divide by 4, and we get x equals negative 3/4. And also, of course, x equals 0. So we have a couple of answers here, and they will be x equals 0, comma, negative 3/4. Now, this is not an x-y ordered pair. This is a solution set for x. These are all the possible values that x could be for this equation that we started with. And it's all by virtue of factoring the GCF and zero product property. So let's take a look at one more and then we'll be done with factoring the GCF. Alright, so we want to factor the GCF in this guy, and hopefully you believe it's rather straightforward. If you want, you can pause the video and do it yourself first, and then see what I say. Hopefully you paused and tried it yourself. Now let's see what I think. There's a common 3 that's in all of these terms, so I'm going to go ahead and take out that 3, and that leaves us with x squared minus 2x plus 3. Now, in this example, it's possible that I could factor some more. It's possible this could be factored, but all I wanted to explain was factoring the GCF. So I've accomplished that. I factored the GCF out here. Now, I want you to notice that when I factored this 3 out, the 3 itself cannot possibly be part of the solution. Okay, look at what the deal is here. Is 3 is not 0. So the 3 has no impact on the solution whatsoever. What we'd like to do is maybe with this guy, we'll learn some new techniques later to figure out how to factor this to use the zero product property. Maybe we can factor this. Maybe we have to use quadratic formula. Anyways, I at least wanted to show you factoring the GCF when there's more than just two terms. All right, let me throw one more at you before I'm done with factoring the GCF, because this one's so powerful. There's an equation that tells us how things fly through the air. It's called projectile motion. And it looks a little bit like this, what you see right here. And, h equals negative 16t squared plus 80t. Notice I didn't mention this thing here. I just said h. This is the height of an object. And t is time in seconds. H is in feet. And this is time in seconds. Also, this t is time in seconds. And this particular formula tells us where an object is, how high an object is with regard to how much time since it was launched, like maybe by a catapult or by a gun. And so just to give you an idea, just to give you a visual, maybe something like this, if we had something like this, if this was the graph of the object over time, here's time over here, and here's its height. The graph of the object going through the air might look something like this, okay? Turns out that it's parabolic, all right? And you've seen this before when you throw things somewhere. Anyways, this is the graph of height versus time. It's going up, up, up. Eventually it stops going up, and then it starts coming back down as time goes on, right? So anyways, if we wanted to figure out when this object is going, how long it takes for this object to hit the ground, what we do is we set h equal to 0 because h is height, and if we want to know how long till it hits the ground, well, we want to know what will the time be when the height is 0 feet or the ground. So I'm going to go ahead and plug in 0 equals negative 16 t squared and plus 80t. And I just want to show you what a breeze it is to solve a problem like this when you know how to factor the GCF. In this case, there is some, some common factors. There's a t that's common to both of these terms. And again, here's a term and here's a term. Terms are things that are added together. And so what we do is we just factor out what is common between the terms. The easiest thing is t. So I'm going to go ahead and just take a t out, and that leaves me with negative 16t plus 80. Now, it turns out I could factor more out if I wanted to, because 16 and 80 have common factors, but I'm not even going to bother. I'm just going to solve this as two separate equations right now using now that I've factored the GCF, I'm going to use zero product property. First of all, this thing is going to be at a height of 0 at time t equals 0, because look, if this times this equals 0, then either this is 0 or this is 0. So t equals 0 is one time when it's on the ground. It turns out we're launching this object from 0 height, from the ground. So naturally at time equals 0, here's time equals 0, we're at 0 height. All right, so then the next thing is we'll set this guy equal to 0 and find t. So 0 equals negative 16t plus 80. And now this is a simple linear equation, and you already know how to solve this thing. So I'm not even going to bother. I just wanted to show you that I could find the value of t by factoring the GCF and then using the zero product property. That's a pretty powerful tool. Factoring the GCF can actually let you solve complicated problems like projectile motion equations. Okay, that's it. Factoring the GCF. I'm out of here.